Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to show you how to write the molecular, complete ionic, and net ionic equations for the reaction with barium nitrate and potassium phosphate. So let's get into this. So here you'll notice that they give you the two reactants with the names of the compounds rather than the formulas. So you need to know how to convert from the name to the formula. And so if you don't know how to do that or need a refresher, please go to my earlier videos where I go over how to do that. I'm going to go over how to do it in this video as well. So, so for the ionic substances, the ions are in the name. So barium is your first ion, nitrate is your second ion. So you need to know the formulas for those as well as the charges on those. So barium, that's a Ba. So barium is in group 2. It's a group 2 element. So that means the charge is going to be a +2. So for those of you who don't know, there's two ways to figure out the charge. One is you can memorize the rule that is for your group A elements 1 through 3. So 1A, 2A, and 3A for the main group elements. The positive charge, excuse me, the positive charge of the element is equal to the group number. So if you're in group 1A, then you've got a positive 1 charge. If you're in group 2A, you're going to have a positive 2 charge. And that follows for the groups 1, 2, and 3A. And so since barium is in group 2, it has a 2 plus charge. The other way you could think about it, and I think the better way, is keep track of your valence electrons. So you should know that the group number is equal to the number of valence electrons for the elements in that group. So if you're in group 1A, then you've got 1 valence electron. If you're in group 6A, then you have 6 valence electrons. And so knowing the number of valence electrons will help you figure out whether it's going to gain or lose electrons. So for barium, it has 2 valence electrons because it's in group 2A. And so it's very easy for that to lose the 2 electrons and get that noble gas configuration. So remember, they're trying to get noble gas configuration, which is a complete outward shell, outer shell for the electrons. And so by losing those 2 electrons, then it will have a complete outer shell. And so it'll do that. But by losing the 2 negative electrons, then now it's going to have 2 protons that are positive that are not being balanced by those 2 electrons. And so you get a 2 positive charge. And so you got 2 positive here. Nitrate is the other anion, the other ion. It's a negative ion, anion, and so it's also a polyatomic ion. The polyatomic ions, you just have to know. You're going to have to memorize them. Your teacher probably gave you a chart of some sort with polyatomic ions to memorize. I have a video on how to help you memorize these and to look at patterns to help you remember what the charges are and what the formulas are. So you can look at that video as well. So for nitrate, you have to know that it is an NO3 formula and it has a -1 charge. So here we have the 2 ions for barium nitrate. And so now all we need to do to do the formula is to balance the charge. We need to write the formula so that the charge of the compound is neutral. So we notice that this has a 2 plus charge, this has a -1 charge. So we're going to need 2 of our nitrates to balance 1 barium. Another way you can do that is use the crisscross method. And so that's where you take the numbers of the ions. So there's a 1 here. And so we would put the 1 down there, the 2 would go down there. And so you would write Ba. We don't write the 1. And then since we have 2 nitrates, whenever you have more than 1 polyatomic ion, you have to use the parentheses. So we have 2 here. So I'm going to have NO3 in parentheses, and I'm going to have the 2 on the outside. So here's my formula for that reactant. So, and then I would do the same thing over here. Potassium is K. Potassium is in group 1, so it's going to have a +1 charge. And then phosphate is another polyatomic ion that you have to know. And phosphate is PO4 and has a 3- charge on there. So again, you can see that when we're writing this out, for the formula, we need to have a neutral charge. So you'll notice that I have a +1 charge on my potassium. I have a 3- charge on my phosphate. So I'm going to need 3 potassiums to balance. I can also do the crisscross method, right? So the 3 goes down there, the 1 goes down there, and so of course I'll have K3PO4. So I'm going to write it on this side here. So plus, so that's going to be K3. I need 3 potassiums to balance the charge on 1 phosphate. And so now I have my two reactants, and so now I'm going to have to figure out what the products are. And so, as you can see, I have 2 ionic substances, and so whenever you have 2 ionic substances, that's a big giveaway that you're going to have a double displacement reaction. So what does that mean? That means that when you figure out your possible products, you take the inside ions and put those together, and you take the outside ions and you put those together to form your products. And you got to make sure you balance the charge. So the nitrate is going to go together with the potassium, and the barium is going to go together with the phosphate. And so barium has a 2+ charge, phosphate has a -3 charge. So again, you could do the crisscross method. So barium has a 2+, and phosphate has a 3-. And so the 3 would go down here, the 2 would go down there, and then we would have to write our formula. So that would be Ba, barium 3, and then our phosphate, we would have 2. So we're going to need parentheses PO4, 2 on the outside. So that's one product plus, and then for our second product, where nitrate and potassium are going to go together. Potassium is a +1, nitrate is a -1, so it's a 1-to-1, so that's easy. So we're going to have KNO3. So now we have our products, we have the formulas for our products. Now we need to balance the equation and figure out what the states of matter are. So we have 1 barium here. I have 3 bariums here. So I'm going to put a 3 coefficient to balance that. I have 3 potassium here, but I have 1 here. So I'm going to put a 3 there to balance the potassium. So those are balanced. I have 3 times 2, which gives me 6 nitrates. So I have a 2 subscript. To find out how many nitrates I have, I just multiply the subscript by the coefficient. So that gives me a 6. So I have 6 nitrates on this side. Here, I only have 3 nitrates. So I'm going to have to change that to a 6. So let's go ahead and change that. Well, let's come back to that nitrate in a moment. Let's look at phosphate too. So here I have 1 phosphate, but here I have 2 phosphates. So that's going to have be a 2 there too. So if I change this, we said that this was going to have to be a 6. So let me erase that. Oops. All right, so I'm going to have a +6 there. So now I have 6 potassium, and I need to put a 2 there for the 6 potassium. So that's balanced. And then when I do my phosphate, I have 2 phosphates there, and now I have the 2 phosphates. So now I have a balanced chemical equation. Okay, so now the next thing is to figure out what the states are. And so this is where your solubility table or a solubility chart. Your teacher probably gave you one of these. You can find one easily on the internet. So you're going to use that to figure out whether or not you have a solid or aqueous for your ionic substances. So for nitrates, the rule for nitrates is that all nitrates are pretty much soluble. There's really no exceptions or very few exceptions for nitrates. So if you've got a nitrate, it's soluble. That means it's aqueous. So we're going to have aqueous here. So that's aqueous. And phosphates, what's the rule for phosphates? If we look, it says all salts that contain phosphates are insoluble except for group 1A elements or metals. So if you have a group 1 element in your with your phosphate, then it's going to be soluble. So here we have potassium. Potassium is a group 1A element. So this is soluble. It's aqueous. So this is aqueous. And then now we can look at our products. So we said before that nitrates are soluble. So this is soluble. So that's going to be aqueous. And then what about the barium phosphate? So again, the rule is, it says that all salts that contain phosphates are insoluble except for what? Group 1A elements and ammonium. So we don't have a group 1A element. We don't have ammonium. So this is insoluble. So that means it's a solid. So we have a precipitate. So now that we have everything laid out, we have our balanced molecular equation. So this is our balanced molecular equation. Now we're going to have to write the complete ionic equation. So when we write the complete ionic equation, all we're doing is we're separating any of the ions that are aqueous. So here, this is aqueous and this is aqueous. Why are we separating the ions? Because in reality, what this means is that these ions are actually separated and they're not together. The reason we write balanced molecular equation, the reason that this is called a molecular equation is because we're writing it as if they're molecules put together, but they're not. They're in reality, they are separated. So that's all we're going to do. So anything that is aqueous, we're going to separate. Anything that's solid, liquid, or gas, we keep together. So here we go. So I'm going to take, I have 3 bariums. So 3 bariums. So that's going to be 3Ba 2 plus. When we do our ionic equations, we write out the ions separately and we put the charges. So any ion that's aqueous, we write the charge for that ion. So 3 barium aqueous. We have 3 times 2 is 6. So I have 6 nitrate ions, aqueous. And again, the reason that I'm doing this is because that subscript does not follow the nitrate. If I put the subscript down here, that's like I'm saying the 2 nitrates are together and they're not. So I have 2 nitrates as part of the formula, but I have 3 of these formulas. So I have a total of 6 nitrate ions floating around together. Not together, but they're floating around separated from each other. So I have 6. So 3 times 2 is 6. So I have to have a 6 coefficient there. Plus, and then I have 2 times 3 potassium. So that's 6. So I'm going to have 6 potassium plus aqueous. And I have 2 times 1 phosphate. So I have 2 phosphate ions. So 2 PO4 3 minus aqueous. So now I have all the ions separated from each other in solution. And so the next thing is to do the same thing with the products. This is a solid, so that actually the ions are together, bonded together in an ionic compound. So that's going to stay together. So we'll just keep that the same. So Ba3 PO4 2 solid. And then last but not least, we'll separate these out. So I have 6 potassium and I have 6 nitrate. So those are going to be separated because they're aqueous. So plus 6 potassium aqueous plus 6 nitrate minus aqueous. So this is our complete ionic equation. And so it's still balanced because we haven't done anything except for separate the ions. So now that we have the ions separated into our equation, this is our complete ionic equation. Now we need to do the net ionic equation. And the net ionic equation is where you are separating out the ions that are not part of the reaction. So they are the spectators. Just like in a sporting event, the spectators are in the stands. They're not doing anything. They're just watching the game. The players are on the field doing the hard lifting and whatever. So in this case, we have the same thing going on. 2 ways to figure out what the spectator ions are. One way is to look at the product that's formed. If you have a solid, liquid, or gas, the ions that form that substance that is not aqueous are the players. So here we have barium and phosphate forming a solid. So those are the players. Everyone else are spectators. The other way is to look at both sides of your equation. So if you have a substance that is aqueous on both sides, if there's no change, then that's a spectator. So here I have 3 barium ions, aqueous. Here I have 3 bariums, but it's part of a solid, so that is a change. So barium is part of the reaction, so I'm going to keep barium. What about nitrate? I have 6 nitrate aqueous and I have 6 nitrate aqueous. No change. So that's a spectator ion. So I can get rid of that. Potassium. I have 6 potassium plus aqueous and I have 6 potassium plus aqueous. No change. So that is a spectator ion. So we can get rid of that. And you can see that the 2 phosphates go in to form the solid. So that is part of the reaction. So then all I do is I write what's left. So 3Ba2 plus aqueous plus 2 phosphate, 2PO4, 3 minus aqueous. And then that's going to go to your barium, Ba3, PO4, 3. Oops, that should be a 2. 2 solid. So this is your net ionic equation. And so these two come together to form your solid. I hope this was helpful. I hope you learned a lot from this video. If this really helped you and if you like this video, please hit the like button. Please share the video. Put a comment in the comment section. Let me know what you think and if you have any questions. Also, make sure you subscribe to my channel, hit the notification bell, and so that way you can get notified of any other videos I put out. Thank you for joining me. Have a great day.